Okay, so now we will now do what's called the next model. It's called the two-way classification model. So here, what we do is we have a model with no interaction, but and one observation per cell. That's the idea. So here's a model with no interaction, and one observation per cell. So key things is that this is the no should be understood properly, and then you only have one observation per cell. Okay? So then what you do is, so the idea is that, let's say you have this, let me write this down. So on each of the rows, you have what's called treatment, let's say. So you put treatment. So treatments on the rows, let's say. So each of the rows is a treatment. Write again. So make it small, put there. Treatment. Treatment. Each of the columns, you think of it as a block. Okay, so let's say you have you keep going down like this on this row. You have, let's say, a J block. Let's say so. You have the first block. The first block. Then you go all the way across. And your last block is, let's say, the Jth block. Block you have, and then in each of them, each of the blocks, you have each treatment you put. So you put, let's say, the first treatment. Let's call it as the first treatment. And then, so you go all the way here. If you just do this, it's just y1 dot. So the first row. Right? And then you keep going down, you go up to the ith treatment. So the ith treatment, right? So now here will be this the first column, and this is the ith column, jth column. Oh, yeah. So it's like an I cross J matrix, right? That's what you have here. And this is the total, let's call this y dot dot. So sum everything up, you get y dot. So what are you going to assume with the model? You're going to think of the model as, the model is going to be, so each yij is going to be one mu, that's common mu. It's going to have some dependency on the I, then plus some dependency on j, and then plus an epsilon ij. Okay. So a little different from the single one-way classifications, because I have one less than equal to I less than equal to capital I, one less than equal to j less than equal to capital J. So essentially you have individuals in each block, and let's call it, let's just come here and let's just, this cell maybe here is jyij. What I have. So each y is modeled like this, is mu plus alpha I plus beta j plus epsilon ij. It's a two-way classification model. So then here what will happen? Here your total observations you have is just I times j, that's nj, right? Then let's call that m, that's n. And then m is just going to be by sum over all the i's and the j's, and I get a 1 plus I plus j is now m. And I'm going to have this parameter called r. I'll explain what these things are in a second. R is going to be just 1 I minus 1 plus. These turn out to be degrees of freedom in the appropriate sum of squares, but I'll write as. So it's just going to be I plus j minus 1. Here again, one can check what are the estimable linear functions. Estimable linearly independent. Independent linear parametric functions. Functions. So here you can easily check that what are they going to be? They're going to be mu plus alpha bar plus beta bar. That's one guy, right? Then everybody else will be difference of guys. Right? So alpha I minus alpha I prime, right? So you just do for 1 less than equal to I, not equal to I prime, less than equal to capital I. You can do all those. You can also do beta I minus beta j minus beta j prime for all 1 less than equal to j, not equal to j prime, less than equal to capital J, right? And here your alpha bar is just the same as mu plus 1 over I, the sum from I equal to 1 to I alpha I plus 1 over j, sum from j equal to 1 to capital J of beta sub j. Right, so these are the estimable functions that you can have very independently. So now you can do how do you do the least squares? You can do a least square estimate for this, right? So how do you do least squares? Your residual error, your error is going to be what? It's going to be, if you want to estimate this, let me write down the error of this parameter, right? Of mu, the alpha i's, let's call the alpha as the vector, and then the beta as the other vector, is going to be what? It's going to be just, you're going to have the sum for I equal to 1 to capital I, sum over j equal to 1 to capital J, right? You'll have yij is your thing, and then minus mu minus alpha I minus beta j whole square, right? What you get, right? So from this, you can just use calculus or otherwise. You can use calculus or otherwise. You can use calculus, or you can use linear algebra if you like. Right? What will you get? You can get the least square estimates for these guys. I'll write this thing down. So let's say, so I think if we get mu hat, if we do a mu hat plus alpha bar hat, let's say, alpha bar hat plus even beta bar hat. The beta bar hat does the thing. You can get that to be equal to, I think it'll be the total mean, that is y dot bar. It's just the same as 1 over I times j, the sum from I equal to 1 to capital I, the sum from j equal to 1 to capital J of yij. And that you could think of it again as the total t double dot by ij. And then you can also do this, if you do the equations properly, you'll get mu hat plus, let's say, alpha I hat plus, I think next one will be beta bar hat. This guy will just be the same as the ith mean, that is yi dot bar rather than y dot bar, which is same as, let's say, I'll call it as ti by I. This is true for all 1 less than equal to I, less than equal to capital I. So now you can reverse the thing. You can just say again, mu hat plus alpha bar hat plus beta j hat. That will be just the jth column mean. So y dot j is just t dot j divided by j. So what do you get? Right? Very good. So these are the least squared estimates. So now you can use these equations. Once you use the calculus, you can get this, and then from here, you can easily conclude that the least squared from these equations right here that I have above, you easily conclude that the least squared estimates of, let's say, what do you want? We want mu plus alpha bar hat plus beta bar. That's just the first guy. That's just y dot dot bar that we already know. And if you want alpha I minus alpha I prime hat. That's just you subtract two equations from here, you'll just get yi dot bar minus yi prime dot. Let me write it down properly so it's clear. I prime dot, this is yi dot bar minus yi prime dot. And similarly, you get the other one is just a beta j minus beta j prime dot hat. Not here, I guess. J prime, that again is the same thing as y dot j bar minus y dot j prime bar. Okay. That's one way of getting it. And then if you want the entire thing, mu plus alpha I plus beta j hat, the least square estimate, that's just going to be the same as yi dot bar minus the plus y dot j bar minus the total times. Very good. So the estimates, right? So again, you have this R0 and R1 squared, and you could write the F tables down. Let's just do that. So we'll come back and do that in the next recording. So I don't know, I just stop with this. This is the estimate you get for the two-way classification model. Let's just go back and check if we can get this thing done. Let's see if we can get it. It'll make it double. So here we took a two-way classification model. Go back up. So, and then we first discovered that these were the linearly estimable functions with these independent of these guys. Then what you could do is you could go and write the error down, and then you could use either calculus or linear algebra. You could differentiate in mu, differentiate in alpha, different beta, you get the equations, and from that you'll get the fact that the estimates of least squares for these guys are these people. And from this, if you want to get these people, you just have to look at the first line gives you the answer you want. If you want this person, you just subtract two of these guys, so you get yi minus yi bar minus y dot I prime. J, if you want to do the same thing, you get j dot j. And if you want this, you just have to just sub the two means and then minus subtract. Okay,